the next thing we're going to be talking about is how to find the slope of a line. And the slope is a measure of how slanted a line is, whether it's very steep or not so steep, things like that. So let's say we have a line that goes through 2 points, and I'm just calling those points generically x1, y1, and x2, y2. If a line goes through those 2 points, then the slope of that line is y2 minus y1 over x2 minus x1. You may have heard slope referred to as rise over run. Rise is the difference between two y coordinates. Remember, y deals vertically, and run is the difference between two x coordinates. Running deals horizontally. This could also be written as y1 minus y2 over x1 minus x2. So it doesn't matter if you put the ones first or the twos first, but what does matter is you have to have y2 over x2 and y1 over x1. And same thing here. Like the ones have to be on top of the ones and the twos have to be on top of the twos. So what I mean by that, what you could not do is y2 minus y1 over x1 minus x2. That would be incorrect because you do not have, if you're going to put the y2 first in the numerator, you have to put the x2 first in the denominator, and vice versa if you were going to do the ones. So notice that there's also this condition here on the slope for these lines that the difference between x1 and x2 cannot be 0, because if the difference is 0, then we'd be ending up with 0 in the denominator. And we just spent lesson 3 talking about how we cannot have 0 in the denominator. And we will see what happens to the slope when that is in fact the case. So let's look at some examples. Example 4, I'm going to find the slope of the line that passes through these points. I'm going to choose to call this point x1, y1, I'm going to put it on top, and x2, y2. It doesn't matter if I had switched those points around, right? If I had called the first one x2, y2 and the second one x1, y1, we would still get the exact same answer. So slope formula tells us that slope is y2 minus y1 over x2 minus x1. So y2 is negative 8. Subtract y1, which is 3. And then by that we are dividing. X2 is 1. And then we are subtracting x1. Be careful with your signs here. The slope formula already has that subtraction there. And then what we are subtracting is a negative 2. In the numerator, we get negative 11. In the denominator, I'm going to just take a second to write that as 1 plus 2, because those two negatives come together to make a positive, to give us a slope of negative 11 over 3. And then I also want to quickly sketch this line, just so you can see what it looks like, a rough sketch. So let's say the point negative 2, 3 is about right there. And then the point 1, negative 8 is about right here. And so this line looks something like, well, not that, but something like this. Okay. And we can also see that this line had a negative slope, right? We got a negative 11 over 3 for that slope. Now let's look at example 5. We're going to do the same thing. We're going to find the slope of this line. Just for the purpose to prove my point, I'll now call this one x2, y2, and I'll call this one x1, y1. It doesn't matter which ones we call them, as long as one point is the 2's and the other point is the 1's. So like you could not say, oh, that's x2 and this is y1. You can't do that. Okay, so let's apply the slope formula, that m is equal to y2 minus y1 over x2 minus x1. y2 is negative 0.4. From that, we are subtracting 1.3. And then we are dividing. I'm going to go ahead and grab my calculator. x2, which is 0.1, minus x1, which is 0.8. So in the numerator, well, negative 0.4 minus 1.3 is going to be a negative 1.7. And in the denominator, 0.1 minus 0.8 is going to be a negative 0.7. And 1.7 divided by 0.7 gives us about, I'm just going to round this to one decimal place. It's about 2.4. So now, same thing, I'm going to plot these points just to give us an idea of what this line looks like. The point 0.1, negative 0.4, let's say that's about right there. Just go right and down a little bit. And then the point 0.8, 1.3, I'll say that's about right here. These are very rough estimates, okay? As long as we place things about where they should be, we'll be fine. Because I want you to see what a line looks like if it has a positive slope, right? So this line, we calculated the slope and we got 2.4, that's positive. So let's just compare what those two look like. Negative slopes, positive slope, right? And we'll generalize that in a second. Let's look at examples 6 and 7. Example 6, find the slope of the horizontal line y is equal to 4. First thing I'll do is I'll just graph that line. Notice that I am labeling my x and y axes every time I create a graph. And you will label your x and your y axis too every time you create a graph. I don't like that that's crooked. So the horizontal line y is equal to 4 looks like this. It goes through 1, 2, 3, 4 on the y-axis. We have been finding slope so far by using the slope formula, which requires us to have 2 points that are on the line. So let's just find 2 points that are on this line and then apply the slope formula. So one point that's on this line is the point 0.4, right? Another point that's on this line is the point negative 2.4. Doesn't matter what x coordinate. I can pick any x coordinate I want to pick. As long as the y coordinate is 4, it will be on the line. So I'm going to use those 2 points to find my slope. I'll say this is x2, y2, and this is x1, y1. Those are 2 points that are on the line. Slope formula is y2 minus y1 over x2 minus x1. Rise over run. y2 minus y1 will be 4 minus 4. In the denominator, x2 minus x1 will be 0 minus a negative 2. So I get 0 over 2, which is 0. It's perfectly fine to have 0 in the top of a fraction in the numerator. 0 in the numerator is 0. It's not okay to have 0 in the denominator of a fraction. So we found that the slope of this horizontal line is 0. In fact, the slope of any horizontal line will be 0. Because if you're dealing with the horizontal line, the numerator will always be the same number minus the same number, right? Because all the points would have the same y coordinate on a horizontal line. So what I mean by that is, for instance, even if I would have used 5, 4, I still would have had that y coordinate of 4 on any 2 points that I chose, and I would have subtracted them to get 0 in the top, which will always give me a slope of 0 for a horizontal line. Let's look at example 7. Find the slope of the vertical line x is equal to negative 3. First thing I'm going to do is I'm just going to sketch that line. Here are my labeled axes. The line x is equal to negative 3 is a vertical line, goes through negative 3 on the x-axis. I can clearly see right here that the point negative 3, 0 is a point on that line. That's the only x-intercept that line has. And another point on that line might have been negative 3, 3. You could choose any of these points, negative 3, negative 6. It doesn't matter. As long as your x-coordinate is negative 3, it doesn't matter what y-coordinate you pick, you'll be on that line. So let's say this is x1, y1, and this is x2, y2. Slope formula is y2 minus y1 over x2 minus x1. I'm going to start plugging things in now. When I plug in y2, I have 0. When I plug in y1, we have 3. When we plug in x2, we have a negative 3. And when we plug in x1, we have a negative 3 as well. So we are subtracting a negative 3. Again, be very careful with your signs there. There's already a minus sign in the slope formula, and then we are subtracting a negative number. So those two negatives will come together to give us a positive. So in the numerator, we just have a negative 3. And in the denominator, we have a negative 3, careful with signs here, plus 3. And negative 3 plus 3 is 0. And that's problematic because we're not allowed to have 0 in the denominator. In fact, we saw back in lesson, hopefully I can pull this up quickly, lesson 2, I believe. I just saw it. Here we go. Here's an example where we had 0 in the denominator. What did we get? Something that was undefined. 0 in the denominator is undefined. So this slope for this vertical line is undefined. In fact, the slope of any vertical line will be undefined because you'll always be subtracting the same x coordinates in the denominator. So to generalize what we have seen, if we're dealing with a line in standard form, like we did in the first example, if both a and b are not 0, that line will have some kind of slant to it, some kind of slope to it. And it could be a positive slope running in that direction, or it could be a negative slope running in this direction. We saw an example of a line with a positive slope in example 5. And we saw an example of a line with a negative slope in example 4. Horizontal line has a slope of 0. We see that happening in example 6. And a horizontal line will always have the form of y is equal to some number. K is a constant. K can be any number. It's just telling us where that line is going to hit the y-axis. And any vertical line is going to have the form x equals a number. We can see that in example 7. We also saw that in example 3. No, we also saw that in example 2. And we also saw a horizontal line in example 3. Okay. And any vertical line is going to have an undefined slope. So slope can be positive, it can be negative, it can be 0, or it can be undefined.